Yo, yo. I did not even check last time if the opening to my video got cut off. Oh well. I'm just gonna keep opening hard and fast. It's time for another episode of It's Just a PC. So last time we managed to get the characters all working from the ASCII set. Only took us about 2 hours, and most of the characters are terrible. Because what you gonna do? They're a character set made for the backgrounds of a game, not for text. But I knew that was gonna happen. That's not a surprise. We did the best we could. Today, as we work to wrap up the character output portion of this project, I'm going to implement control characters. At the very least, get like line feed, carriage return, backspace working. I don't know about backspace. I'm gonna implement backspace. I'll implement backspace as a control character. I think I won't do anything special with it because that is probably what BASIC assumes. I will probably have to Jooj all of this up a bit once we actually start pulling in basic code, because I'm making assumptions on what characters it will even be sending to my character print routines. Excuse me. And so I'm going to make the assumption here that I think is not too crazy, that BASIC probably sends a backspace, space, backspace series of characters, or something similar to that, in order to backspace a character. Or potentially Microsoft BASIC just might not even support backspace at all, because a lot of stuff back then didn't really. I suppose I could go check on the BASIC on the Apple II, but whatever. We're just going to make some assumptions, and we'll fix it up later when it turns out that it doesn't work that way. But I might get to scrolling. We will see. The main thing is these control characters should be relatively simple. It's that I have to edit my logic for controlling like the cursor position where the text is displayed. And I might want to print a cursor too, honestly, just throw an underscore wherever the current cursor is and keep that up to date. But I won't make that a goal for today necessarily. But right now, let me see if I can find the code since I have the screen up. Hello, your mom. Hello, Santiago. And hello, Gerald. Good to see everybody. I always have a crowd, and that is always fun. Anyway, so the actual code where I was handling, like right now I'm only handling incrementing the screen X value, which is a single byte value somewhere in the 0 page. And I do have a screen Y value in the 0 page, but we're not using it for anything right now. What I was thinking earlier is, so my core issue right now is that the address in the PPU where I'm putting the character tiles when we write them is a 16-bit address, which makes sense because the screen area is more than 256 positions. So you'd want it bigger than a byte. But that creates difficulty for me because, you know, I have to transform my screen Y and screen X coordinates into an actual location on screen. What I'm doing right now, I guess I actually am using the screen Y value. I'm just not... I'm using it in the code, but I'm not using it when I place a character, because I'm only incrementing the screen X, and so we get characters when we run past the end of a line just by dint of the fact that, you know, the number, when you have the screen X is more than a multiple of the line number, naturally it goes down to the next line just because that's how the addresses are laid out. But we want to do that properly. And that makes another thing occur to me, is that I also actually want that to be handled properly so that when we do wrap, we actually increase the Y coordinate properly so that we know where it is. But my first thought here was, what if I keep a whole separate screen Y and screen X value to keep track of where in XY the cursor is? But for most normal character printing, update screen X and screen Y, but also just keep a separate like screen address 16-bit value in 0 page, so that I can just increment that and I don't have to every time loop through Y and add 20 Y times to calculate my value, because it's just slow, right? Like if the Y is just 0, then we only have to add 20 once and we're done. Or, you know, we add it 0 times. Our 0 is 1 in this one because we don't use the top line. So right now it's 1, so we go through this loop 1 time, increment it by 20, and that's it. But when we get to the bottom of the screen, we're going to be doing that many a times. So I think it makes sense to not recalculate it every time and just keep track, so that perhaps in the future, if I, like, because right now it's not like we have like a cursor repositioning command or anything, so the only thing that's ever going to happen is the cursor moving forward by 1 location or back by 1 location. So I think just updating our X and Y and then maintaining an actual address value is fine. And if I ever want to do character placement commands later, then we can, you know, we'll just detect, oh, this isn't just 1 greater than the previous value, so actually recalculate. So maybe how we can do that. But I'm going to do it the cheap, easy way for right now. So let us reserve some space for... What the heck? I'm going to close this and not save because I don't know what I just did. Anyway, we're at the top of the code, which is where I wanted to go. So yes, let us allocate. And I could also do this by using some more complex structures for allocating areas of memory in my assembly, but for now, I'm just going to manually define 0 page addresses that I'm using. So anyway, our string pointer is 16 bits, so I will also make sure to start this at 5, and this will be, let's call it, or no, let's move the string pointer actually, so we keep these together-ish. So screen X, screen Y, and then screen address. Oh yeah, so, because right, when we do a new line, well, when we do a new line, we'll just add frickin' 20 to the address. And you know what, to that end, does it even really matter having a screen X and Y? Because I was figuring, like, we'll need them for keeping track of stuff, but, like, for right now, we don't need that. Like, there's nothing in particular, I think, that would really care about those values. So screw it. Let's just have our 16-bit screen address field, and that is it. That's all I'm going to use for now. Why overcomplicate it? So print character. Where am I even going? So screw this. Don't even use that. Don't increase X at all, because it doesn't exist anymore. And what we'll do is we will, let's see, we will just load, well, you know what? Let's check what the character is first. If it's one of the control characters, we will handle it in a very specific way, instead of just calculating the XY value. So let's just delete all of this code right now. And you know what? When we start up, let's also just add initialize print location 1 1 on the playfield. And so for this, we will just set load a what is that going to be? So it's going to be 20, and then I'm going to add at least 1 to it, because it's 20 to move it down 1 line, because each line is 32 tiles wide, and then I'm going to scoot it over 1 position, because when you're actually rendering it on a TV, the left-hand line also falls off the edge of the screen. So we are going to have like a 30 by, I can't remember how many characters tall it is right off the top of my head, but 2 less than how tall the actual map is. Screen, I think, is my plan, as far as what characters are actually available. So let us load in 21. Actually, sorry, this is going to be 2021. The beginning of the map memory is 2000, and we are setting the high byte of the PPU address to write to, and then the low byte. So the and this is actually funky because we're not really using this as a 16, like the 6502 supports 16-bit numbers for addresses in certain addressing modes, in like indirect, like page indirect mode. But that's the only place that endianness really matters, so I can put this in whatever endianness I want. Maybe I should just stay consistent with machine endianness. Why not? So let's actually, 21 will be the low byte, and I will load that into screen, the first byte of the screen address value, and then 20, which is the first bit, because again the whole address is 2021, because it's the base address of 2000 in video memory plus down 20 hex to the right one. And we will store that in screen address plus 1. Not plus Q, plus 1. And that will give me a semi-reasonable place to start printing from. So, let's see. If actually, I suppose, you know what? We should attempt printing our character. If there is no character in the lookup table, do nothing, you know, as far as putting a character in that spot. Then increase the address to write to if it was a control character or a non-zero character. Right? That makes sense? So, let us... We're always going to wait for vblank first. I might fix that up someday, but we're not doing it right now. And is there a reason I'm doing this right now? I think that was possibly just for the math that was already here. And we're gonna write the current character at wherever the address was currently set to, right? So if it is a non-zero, so if it was 0, let's branch to, let's rename this check control. And this is where I will write the code to check if it was a, we don't have to handle space because we're actually printing a space character. But I will check if it's a line feed, a new line, or a backspace. We'll do that in a bit. I don't think this is actually doing anything. Pull A definitely is. Oh, and then it's moving into X. And yes. So I don't think the clear carry is doing anything. I think that was only for the math bit. This is... You know what? We can save some instructions. Let's just do TAX here. And then we don't do anything with X. In fact, we weren't doing anything with A either, because that was only there because of the math to multiply by Y. So that's way easier. We just, first thing we do, or hell, we could even get it closer to the code that it actually belongs to. There we go. So here we're not messing with A, so this is fine. Then we put A and X, look up the character in the table. If it was 0, we will jump to our check control code field. If it was non-zero, then we know it's a character, so we print it. And I have to load the address here, so we're going to do load a screen address. I can do this in either order. Let's do, oh no, because I'm writing the same address to set the address register. So we have to write the high one first, which I did this in machine order, right? Yes. So it is screen address +1 because we are little Indian. And so we load whatever the high byte of our address is. We store it at 2006, which is the PPU address register. Then we load the low byte of the address, store it at 2006 again, because that's how the PPU works. And then finally, yes, we are going to have to stash A, so let's do another TAX just for fun, because that is faster than putting it on the stack. Then let's do TXA to get it back out from X into A. Then, actually, is store X command? Let's find out. Or I could just use X here, either way. Let me see, because I think that might be a thing. I have lost my mouse. Oh, store X. It looks like that is a thing. Very cool, very cool. So, and so presumably also load X is a thing. Yeah. Looks like there are a few of them. So you can load 0 page with a Y offset. Well, I don't care about any of that because if I was going to use it here, yeah, let's just use it here because we don't need to do any fancy addressing. And then store A, because our actual calculated character tile is in A. So we'll use X for the math here so we don't have to move crap around. And that is that. Except for the part where now we have to advance the, I guess, cursor. So now, let's be clever. So we already have. Oh yeah, this could be good because we just loaded the low screen address into X. So we already know that's there, and the first thing that we want to increment is the low portion. So. Paranoia Man, clear carry before all of my math operations. And then let us, wait, can we just use increase X? Will that set overflow? If increase X sets overflow, that's super cool because that will be fast. Increase X. It sets 0. So that should be good enough, because if we do branch on equal, then, yeah, because if we go over FF, then it should roll over, become 0, then we can detect that, branch on 0. Perfect. And then I don't have to clear carry because it doesn't even use carry. So it's in X already, increase X, and like I just said, branch if equal, because that's the same thing as branch on 0. Wait, branch if not equal. So if it didn't set the 0 flag, then we know we didn't roll over back to 0, and we don't have to increment the high order byte. So yes, so branch if not equal to print char end, because we're done. Oh wait, no, we do need to store it though. Let's make sure we do that. So store x screen address, and subsequently, if it did roll over, then we need to also increase the high order byte. And let's just do that the same way, why not? So that I don't have to load an immediate value. So load x screen address +1. I could probably do some fancy shit where I loaded that into y. Is store y a thing, or can you only store x? I'm getting too fancy. Yep, you can store y. You can load y, probably. So, I mean, if I can load and store y, F it. Let's just hold y here. In y is a command, right? Heck yeah, it is. And let's just make dang sure increase y also sets the 0 flag. Well, that doesn't really matter because we're not gonna roll over. We're not gonna roll over in that case. Yes, so yeah, we're just gonna keep the high order one in y. We're gonna keep the low order one in x. And then after this point, we're done with a if we need it, but I don't think we need it. So x is screen address, which we increase and store. And if it was not 0, then we're done. Otherwise, y, the high order byte is already in y. So all we need to do is increase y. We don't care about that overflowing. I mean, we would, but if it overflows, we're gonna have to handle scrolling. So we'll get there when we get there. But otherwise, we increase y and store y to screen address +1. And yeah, I think I may have just written good 6502 code just now. I feel pretty all right about that. I feel like I have utilized all the resources at my command. Cool. So I guess for starters, I'm not even going to do anything in check control. I just want to make sure that these changes generally work and we still get the same printing across the screen the way that we always have, and that I haven't regressed anything. Oh, I suppose what we need to do here for sure is clear carry, paranoia, and branch carry clear to print char end, because we are done. Right, and that will jump over check control, which will have some code in it, perhaps at some point. We happy with that? I feel okay with that. Let me see. Gerald says, actually Santiago says, does the SDCC have a port for the NES's CPU? Does it add too much overhead to use it? I like assembly, but lately I'm lazy as hell. You can. I've actually seen, there's like a whole library for using, I don't know about SDCC. Oh, well, Gerald says supports the MOS 6502. But what I'm using here, which I have not used until this series, so about a week and a half ago, is this is CA 64, which is a 6502 assembler, but it is, we have learned that it is kind of a pain in the butt set up, because it mainly exists to serve CC 64, or is it 65? You'll figure it out, because C needs a bunch of linking and stuff things. My brain, I do this right after work, so my brain is always mushed when we get here, so I'm sorry, you just have to accept that. But anyway, so you might try CC64 or CC65, whatever this is called, because that seems like it would fit your needs. And also, what I was about to say was, I know that there are NES libraries for that compiler. I have seen them, so give that a look. I don't know where I saw that or why I saw that, so you're gonna have to figure that out on your own, unfortunately, but there you go. And Ocelot says hello, and I say hello, Ocelot. Good to have you. So somewhere Screen X and Screen Y are still being used. So let's delete that. Oh, because I was already initializing the screen location here. Oh, right above, and that is completely by accident. I didn't see what code was right here. Right above the code that I set to save our 16-bit screen address variable that will replace them. Brilliant. And built. B-I-L-T. So this should not change at all. It might, but it shouldn't. It says, and it will never... Whoa, what? Fascinating. That's pretty cool, honestly. I like it. I don't know why it's doing this, but it's really mesmerizing. I'm happy with this because we haven't had one of these mesmerizing accident moments yet. So let's just take this in for a second. Make sure my face isn't covering it up so you can get the full brunt of what is occurring. Because I'm just enjoying it. It's meditative. It says until it doesn't. That is true, Ocelot. It's beautiful. Alright, so why is that happening? Let's see if I can... I'll just leave that running, why not? Let's see if just off the top of my head... So it like started at the right location. That seemed fine. It started in the upper left. But it basically seems like it's printing every single character. Well, my string doesn't start at A, does it? So yeah, it's not even printing the string properly. Over and over and over again. So perhaps we are... doing something weird with string pointer. Are these like overlapping? No, string pointer is at 03, screen address is at 00. And those are both labels, so I'm not referencing them directly anywhere. Oh, let's look at this and think about it for a second. So when we get here, A should have the character in it. We wait for vertical blank. Then we take A, we slap it into X. Then we go into the character lookup table using that X offset. And we load it into A. If it was 0, we skip all this shit. Otherwise, we load that value in our screen address variable into Y, store it in 2006, which this seems rightish. It's putting the character at the right place and advancing. I bet it's like a bad label thing or something. We set the scroll, because that always needs resetting, and then we return. Nothing particularly weird there. You know what's actually very interesting to me, now that I think about this? So at the beginning... No, that was balanced. I was going to say I was pushing A on the stack and then not pulling it back off the stack. But of course I was pulling it back off the stack. I was just thinking in terms of if that would have screwed up the return or not. This is using string pointer as a label. Oh, hold up. I think I immediately see what our problem might be. Because in our print string loop, we are using y as our index and not saving it to the stack. We are corrupting the heck out of it. So that could do it. That could do it indeed. So let's say, I don't need to save A because it's just going to get reset on the next loop. Like the caller will expect A to get corrupted. But I should save Y, and even though this caller isn't specifically using X, I should also save X. Might want to save it. Might want to save A too, but you know, in case that will screw up the basic code that we'll eventually be calling into this, but I'm just going to do X and Y for right now. So push X, push Y, then right before we return, pull Y, pull X. Is that in the right order? Yes. Let's try that again. That is almost certainly what the issue is. Are those not instructions? Are those really not instructions? PHX. That is not an instruction. Oh, good lord, what? So I have to take X, put it in A. Yeah, okay, that's annoying. That's annoying. The 65816 is just, it has so many convenience features, and I'm so used to working with that one rather than the 6502. Anyway, so I think we need to push A, then, nope, fat fingers. Transfer X into A, push A again, transfer Y into A, push A again, and then, good lord, because I want to save my A, because I want to use it here, but I will destroy it no matter what I do here, because if I push it at the top, then I have to pop off the X and Y values to get to it. If I don't push it, then I lose it entirely because we're moving we're moving X into it and Y into it, overwriting the value that it had. Good God. Good God, what do you say? Nobody says anything. Nobody has any solutions for me. There's got to be a way to do this. This is like the most common thing when you're calling something in a function that's ever existed. Is it that? Wait, so I just looked for push X. Maybe push Y exists. Sure doesn't. Sure doesn't. Good lord. What are you supposed to do? What on earth are you supposed to do? I am just scanning for any instructions that might help me even a little bit. Like, the only thing I can think is just make a scratch area in the 0 page and throw my incoming A in there, but that just feels like that's... I have a stack right there. It's right there. Yeah, I can push and pull the status register. Yay. That's not really useful. And that's more or less it. That is awful. That is so awful. Hello, Wereworm. I'm just trying to figure out how to save my variables. You know, I guess this would work if the caller was responsible for saving its values, huh? Right? Because if I push Y right before, let's see, if I push Y right before this call to print character, then pop it, then that will work in the way that I need it to, but okay, I guess that's what I'm doing. I don't know what like the standard is for 6502 programming, but this is what I'm going to do. I'm going to have the caller save its clobbered registers, or the registers that are important to it that might get clobbered. Which again brings us back to the what does basic do, and I guess we'll just have to look at it. I've looked vaguely at that code already, so I think we can work around it. But anyway, let's get to it. Let us T transfer Y into A, push A, call the thing, pull A, and then transfer A to Y. There we go. Now Y will be saved. Yay. And I set up my stack, right? I sure hope so. I was using it, but that doesn't necessarily mean anything. Wait for vblank, set our palette values, set the attribute table, set MMC3 stuff. Boy, did I just never initialize the stack. I would believe it. Probably didn't seem important to me at the time. Oh no, I did, right here. We're good. So I don't need to rebuild that. And we can restart this now that it has turned a lovely shade of blue. Oh, also, Wereworm, you'll have to watch back to the first several minutes of this stream because we had a beautiful, beautiful screen filling with random stuff error finally, and it was gorgeous. I do recommend giving it a look. That looks better, but surely carrot was not the last thing, was it? And with our string, I think quote, yeah, double quote should have been, it should be double quote space, exclamation point, hash, ampersand. So it looks right after the first one. Isn't that interesting? Unless I just have my mappings wrong, which is totally possible. Because, let's see. So it's space, or no, it's open parens, space, exclamation point, and then it should be pound, which I know is this block thing. And we're getting the one that I know this one is supposed to be the double quote character, so that's fascinating. Then we get $, which is right. Then we get %do, which is right. Then we get the ampersand fireflower leaf, which is right. Single quote, that's right. Like everything after that looks correct-ish. Let's see. Oh, wait, no. No, it gets weird again. No, it doesn't. I'm just confusing myself. We get numbers. Yeah, I was just getting ahead of myself. All of the dots that are colon and semicolon, less than, greater than, question mark, at sign, capital letters, square brackets, backslash, caret, and then nothing. Nothing at all. How interesting. I'm not even sure. So, why would that be the case? Oh, and it occurs to me, just looking at this, we are definitely going to need some kind of X coordinate counter because we need to know when to roll over the Y address. Wait, no. No, because we're automatically doing that just by increasing the address. We don't need to do that. Ignore that. So still, let's just start let's start by debugging it, printing the first character, because the very first one is wrong. So that should tell us something. which happens at... So it should look like bit 2002 BPL. Let's look at the debugger. It is somewhere around here-ish. Bit, right here. E160. Let's add a breakpoint. E16B. Break on execution. And continue running, and reset. Lovely. And A has 0 in it. Well, that will be an issue already. Why would A be 0? Like, I didn't change anything about this. I didn't change anything at all. Y should be 0. This should load. Oh! No. Wait. And I'm setting string pointer, right? Yes. Yes, I am. I am writing hello string to string pointer. And then I am calling print string. And string pointer is at 0 page address 3. So there shouldn't be any collisions there. Hum. Let me glance at chat really quick. Hello from Toronto, you say? You are real close to me, CPU 133. I am about 45 minutes away from you. So that's cool. And actually, sorry, what I meant to say was, holy Toledo! Because that's what you do. So, what the hell? I guess we have to bop up one level and look at... E199, where print string starts. Yeah, let's do that. Delete this. Add. I wonder if it's some weird wrapping or something? No. Can't be. Wow, what was that address again? E199. E199. And that is all. Run. Reset. Okay. Y is 0. And that looks right. E000 is the location of our string pointer. Or it's the, yeah. It's the address of our string in ROM. So that's correct. And it says that that location has a 22 at it, which also would seem to follow. So A is 22 in it now. Good. That's what we wish. And this maybe screws things up. Let's see. Oh! Oh, what a moron! We just loaded A, then transferred Y into it. I cannot win. Cannot win. Okay. We're going to make this even... We're going to overcomplicate the print string function even more. A function that ultimately we will not need, by the way, because BASIC doesn't need a whole print string function. It's got its own implemented. It just needs to know how to print a character. God damn it. So, actually, let us move... let's see. Well, let's move A into X. We'll stash it in X. Then move Y into A so that we can push Y. And then I don't think I can transfer X directly to Y, because that would be an even better way to save this. No, it wouldn't, because it would get clobbered in the function, just like everything else, which is why I'm pushing Y in the first place. Okay, let us continue then. Pull A. Transfer A into Y, then finally transfer X, which has the stashed A value. Wait. No. We need to do the swap of X back into A right before the print character. That's what we need to do. So transfer x into a. So we stash a in x. A has the character value we just looked up. Then we put y into a so that we can push it and save the value of y from getting clobbered. Then we take a that was stashed in x and put it back in a so that we have the character there. Finally, we print the character. Then we pull the old y value back off the stack into a, then transfer it back into y, and finally increment it. That is some circus bullshit. If anybody knows a better way of doing that, I don't want to know about it. I don't want to know about it. Okay. Reload. Open. It's worse. I have made it worse. There we go. It was stuck on a breakpoint or something. Yeah. Oh, yeah. This is correct. Okay, I might not have been so wrong about that needing an X value thingy to keep track of when we increase lines, because I want to, like I was saying before, I want to actually probably even move down 2 lines. Actually, no, because on the TV, that's the whole thing. This line shows up okay on the TV. Yeah, it does. So I don't need to move it down 1. That's already fine. But this side and this side are falling off the screen. So I need an X variable to keep track of when it goes over this edge. Now, let me think about this, because the lines are 32 bytes wide, right? It's 32 tiles wide. So that is always, 32 is gonna be a multiple of 256. So as we add the low value to the address, we should always just be able to check the low byte. We should just be able to use the low byte and check if the low byte is, I mean, in C you would like probably do a mod on it or whatnot, but I think I'll just have to check with like how many. So that would be your possible values for your X position would be. Wait, can I just like bitwise and it? Wait. The brain is slowly cranking. You know what? Everything below a certain bit will be my X value. Yes. Yes, it will. Because hex 32 is 20, which means that value is the same thing as the second bit in the second nibble of the byte being set. And that increase, that and everything above it increasing, is basically our Y offset. So the first 5 bits, which I think makes sense because what can you count up to with 5 bits? That's 32, right? You can have 32 possible values with 5 bits? Yes, because you can have 16 possible values, or bytes. You can have 16 possible values with 1 byte, so if you add a bit to that byte and you have 5 bytes, you double it, it becomes 32. Yes, so the low 5 bytes of the low 5 bits of the low byte of the video address is always equivalent to our X offset. So, if our X offset, if we and that address, and if we and that value with, so that only the low 5 bits are exposed, then check that to see if it is a certain value. That is how we will know we need to increase the whole thing. I mean, we know we're at the end, so it's not like we have to increase y. Really, all we have to do is add 2, because we want to skip the last one of the current row that we're on and the first one of the next row we're on, so that we end up here. Does that make sense to you? Makes sense to me, but I have been screwing this code up so far all day, so don't believe me. Gerald says, when X wraps, does carry set? No, because again, I just ran through all that stuff, which is really simple, but takes my mind a while to get around. Because it's not a full byte. Carry gets set when you wrap, when you have a byte and it goes from FF to 00. That's when your carry gets set. But our wrap, like X wrapping, is the value going from, what would that be, 1F to 2O, or any equivalent, like multiple thereof, is a wrap in X, or is a, yeah, so. No, that's, Gerald says, oh, never mind me. That's a totally reasonable question. But yeah, if it could be that easy, that would be great, but it is not. So, and I will probably want to, like, sequester this over into its own, like, increase the thing and check if we need to move by a line or something function later, but anyway, so let me think through that again. Which kind of screws up my cool clean code here. Well, let's see. I can use A. A is okay to be dirty after this point when I've written it to video memory right here at this line. So, what say we... oh, right, the only reason they're in Y and X is because of this code. So, let's see. We increase X, and if X is, so 20 would be the next line down, or any multiple thereof, but so if we increased to, if the next character was going to be the last one of that line, which would be the 1F character location, yes, anytime we increase X and it becomes 1F, we need to actually add, basically we just need to increase it again. Yeah, you dig? Does that make sense? Yes, I think that makes sense. Yes. So let us do increase X, and let's not store it yet. Let us yes, we can transfer X into A because we're not using A, and then we can and immediate with 1F, and there's gotta be a better math way to do this, but whatever. Don't worry about it right now. We're just gonna compare it with 1F, and if it is, yeah, there's definitely a better way to do this, but my brain's not in the state to handle it right now. So if it was not equal to 1F, then we just go ahead and, I'm trying to decide if I need to store X twice or if we can work around that. If we branch to my brains. How was this code working originally? That's the part that I've already forgotten. Ooh, okay. Hold up. Let's do this again. I have forgotten my way. If So the current way it was working was increase the X, store it in screen address. Oh, right, we were using BNE to see if X had wrapped 200. That's going to be important. Yes, that complicates things slightly. I guess we still need to check that, because if we increased it the first time and it wrapped, then we still need to do this. Really, I guess what we need to do, I think the reasonable thing to do is, let's not jump to print character end. Let's make a new label. Break not equal, check end of screen. Screened, yes. Here's what I'm gonna do. And same thing here. And check end of screen will be the end of this section. And step character. And this is going to be, there should be an underscore here. And it's a little overkill, because if basically what I'm going to do is I'm going to loop through this again if we calculate that we need to increase X again. And in that case, we definitely won't need to increment Y. Well, no, that's not entirely true. Because on the first pass, it might increment it and not be at the edge of the screen, and then on the second pass, increment it and will be at the edge of the screen. So it is not redundant. Good. Anyway, so in either case, whether it wrapped or it did not wrap, whether we needed to increase the higher order byte or not increase the higher order byte, we will get to this point right here, and actually now, just because of this, we don't need that, but we will need that to skip check control in a minute. So. And at check end of screen, what we will do is we will transfer X into A. We'll do that same thing that I was about to. Then and the accumulator with 1F, compare it with 1F, and branch if equal to step character. Which is fine, because if that happens in the second time through, if this happens, we go the second time through, and we will end up here again, but because it was 1F last time, we can guarantee that it won't be 1F the second time, so it won't just get in an infinite loop, or at least that is what theory I have in my head. And then finally, we will branch carry clear, even though it's probably not necessary, or sorry, clear carry, even though that's probably not necessary, and then branch carry clear to whatever that was set to before, which is print character end. PRNT character end. Okay, that seems good to me. Does that seem good to you? Oh, flaky internet, check mic connection. Whoops. It's also a really cheap capture box, so let me know if that happens again. CPUs should be on PCIe like digital group computers, IDK lol. Also, BIOS on SD card with SPI, LOL. What a great attack vector a BIOS on SD card would be. Indeed. And, I mean, CPUs are on their own bus fabric. Yeah, I don't know. Anyway, let's make sure that builds. Hopefully that builds. Please build. Please run. Please run okay. And if this runs properly, we should see a nice margin on each side of the screen. that mostly worked. Oh, yeah, I need to increase by 2. Damn you. Damn you. Damn you. But I think we can get away with just increasing twice. Yes, because if it's 1x, and if it's 1f and we increase once, again, yeah, we already know it's gonna just be it's gonna increase to, it's gonna wrap to the next multiple of 20, and then we just add 1 to it. So that is acceptable. I can't believe this actually kind of worked. This kind of stuff is really kind of my weakest suit when it comes to low-level stuff, is like coming up with useful ways to use, you know, bitwise math to simplify things. I made it worse. Wait. What? Wait. Right, because that would have reset the flag. Because NX clears the 0 flag. Okay, I'm going to do something real gross. Follow me along on this one. This is definitely not the way to go, but I am going to make a label here. Actually, no, we'll keep step character. That's fine, whatever. I'm going to put an increase x here, and I am going to, let's see, actually, repeat step character, and rename this repeat step character. Then we are going to clear carry like a psycho, branch carry clear, step character. That's real gross. That is super gross, but that is what I am doing. So the first time around, it will branch over this increase x instruction, then carry this out, then check if it was 1f, and not screw things up by doing an increase x right here if that was true. Instead, it will jump to right above here, increase x, then increase x again, and do it all over again. Is that a hack or what? I'm sure there's a better, more righter way to do that, but you gotta admit. The increase x can't be after the BEQ. Oh, you know what? You know what though? Because we could invert that. We could totally invert that. You know what? That would make way more sense, actually. Because what we can do is switch this to a branch if they're not equal. So branch on not 0. Or not, that's actually a compare. So yes, actually branch if they're not equal. And instead branch to print character end. Right, do it the other way around. Then we can increase x here, then clear carry. Yeah, that makes way more sense. Does the same thing, but it's slightly cleaner, and we don't have that funky that funky branch right before we get into here. I'll have to make sure to delete that. Branch carry clear to step character. There we go. There we are. Much better. My God, it built. And reset. And it's still broken exactly the same thing. Same way it was before. Why? If it's not 1F, then we jump to print character end. Otherwise, if it was, we increase X, clear carry, branch if clear carry to step character, increase X again, finally store X. What am I missing here? I have never listened. Actually, that's not true. I started listening to the audiobook of Hitchhiker's Guide to the Galaxy. Maybe I should fast forward to that exact spot where you're saying that my voice sounds like the narrator. Let us read Wereworm's musings, because he always sets me on the right track. Right, the increase X should be after the branch if equal, and 1F, compare 1F, branch if not equal to the end, add 2 to X. Yeah, that's what I'm doing. Check Y, scroll. We don't have a separate Y value, so. What is going on? I legitimately am not following why that's not working now. So let us debug it. Let's debug it. Let me just... Wait, did I actually open the ROM? No, I didn't, did I? You freaking moron. You dummy. I think I just hit reset. I didn't Wow, sorry to waste your time. There we go. It works. So there's that. And again, very pleased that that worked. Not first try, but that my theory on the whole 1F thing actually makes sense. That's pretty pleasing. So now that we have that cleared up, we have done the slight formatting thing that I wanted to accomplish. We have done the actually kind of incrementing lines sort of thing that I wanted. So now we can actually start implementing check control. And we are now a full hour in, so should I leave it to next time? Let's implement one thing. But what should it be? Should we start with... They're all a little hairy. I'm thinking I need to do a separate line feed carriage return. Maybe. Which we may just have to completely rewrite if that's not what BASIC does when it is doing a new line. But for a new line, there's going to be some math here, because we need to basically figure, since we're not actually keeping what X and Y lines we're on, we can't just like, we can, oh, you know what? You know what we can totally do? What those last 5 bits are our X position. We know this. We know that for a fact. We figured that out. That's why this works. So if I just want to do a carriage return, not a line feed. So carriage return is the character that just moves the cursor back to the beginning of the line. I should just be able to and the current values of the address with just the low value too, because we don't care about the top value, because that's only Y offset values, so we don't care. We only need to and mask the low byte of the address with the inverse of 1F, which would be E0. So if we and it with E0, that will automatically roll us back to the... we'll need to increase it by 1 because I'm doing this margin. So actually and it, then increase it by 1. And that should be it. That should be all we need to do for a carriage return. And then that, hopefully, honestly, BASIC uses that for its line feed carriage return, because that's kind of way easier to implement, because for carriage return, all we need to do is just add 20. Well, no, we can't just add 20, because we can't... Wait, no, yeah, because it's line feed, so it's fine to keep it at whatever... We need to keep it at whatever X value it's at. So, yeah, so line feed is just add hex 20, and carriage return is just and the bottom of the thing with E0 to set our X value back to 0. That's it. I love it. I love it so much. That is really cool. So let me check what the status of things is before we jump to check control. So what happens is we take our A value, put it in X, use X to look into the lookup table and load that value into A. And then finally, if it was 0, if that character was 0, we jump to check control. Because we say, oh, it wasn't a printable character. Was it a control character? So A will be what's in there, which is our character code. So we just need to do, let's do compare whatever's in A with immediate. I wonder if it will just accept this. If I just like use, this seems like a really powerful assembler, so I'm just going to give it a shot. If it just automatically will assume that this is an immediate character value, we'll find out. Wareworm says, oh, you go through the step character again? Could have only added a second increase X. I was going through the logic of that because if we... That's probably true, isn't it? Because if we're at 1F, then we know... Yeah, I think you're right. I think I'm being overly complicated. Because we know... No, because I want to... It will... By adding that other X, it potentially... I mean, it definitely will increase our Y value, and increasing our Y value potentially increases the high order byte of the screen address. So I need to go through step character again, or, you know, going through step character again is good because it causes me to do that. Did the low byte roll over? Then we need to roll over the high byte check again. Yes. Which is actually funny because theoretically then we actually don't need that check unless we're increasing the line, because we know that higher order byte will only roll over, or the lower order byte will only roll over into the higher order byte on a increase in the line. But it works right now, so I'm not gonna deal with it. Okay, I have a bunch to read. I'll actually get back to that because it's all very interesting, but not relevant notes on how to do what I'm doing right now in a less shitty way. Okay, so let's just compare it to... Actually, no, this is control characters, so that doesn't make any sense. I won't do that. Compare it to... Because it's by definition a non-printable character, so what am I going to write in a character literal? I should already know these, but I probably have them backwards. So hex D is carriage return. Let's implement that one first. Yes, so if it is D, let's see. Let's branch if not equal to print character, or branch not equal to, because after this we want to check line feed. Yes, and check line feed will be here. Otherwise, we just, let's see. I think we will need to load X. Yes, because we didn't load, we didn't load the value and screen address into anything until we actually start printing a character. So when we get to check control, it's not in there. So I need to do load X screen address. Actually, I can just do load A screen address because I will need to be doing math that you can only do with the accumulator anyway. So load A screen address, which is our low order byte of the screen address, and that with, I said E0, and that should just reset us back. Oh, and then I guess I was going to say, what's better, doing transfer A to X, increase X, transfer X to A, or just doing add literal 1 but add literal one is shorter. So let's just do that. Add with carry, which carry should be clear after that and. Does and set carry? I'm going to start actually thinking about this so that I can not code defensively. Where is and? You know, if I search for and on this page, it's just going to find everything on the page. Yeah, there we go. And where is, yeah. I mean, it all takes me to the same section, but no, that doesn't set carry. That doesn't set carry, so we don't know carry is good here. What does set carry? I guess potentially basically any math. But see, this is why I'm paranoid, is I don't know what all sets the carry flag. And what am I doing just before this? We're doing compare, which probably does. Let's see, yeah, compare sets the carry flag. Right, because it's functionally doing a subtract. And we don't necessarily know whether that carried or not, because we don't necessarily know what the character was, or what the, you know, what the value in A was, so. Clear carry it is! And then add 1, which at this point, this is pretty much going to be equivalent to transfer AX, increase X, transfer XA. So I'm just going to do that. Transfer AX, increase X, transfer XA. You can't stop me. All right, so that will, because we need that for moving in from our margin 1 spot, because I always want to do that. And that's it. Now our next character will be printed next, or same spot. You understand. So yeah, and then after that, because we know it was that control character, then we can finally and doesn't set carry clear. Does increase X set carry? That, like, I just checked that. And we know that won't carry because we just cleared it to 0. It doesn't set carry. God damn it. God damn you, 6502. Clear carry. Branch carry clear. To print char end. Okay, so that should let us actually, I'm going to comment this out for a second. And for hello string, let's do ASCII Z, and what I will do is put a bunch of spaces, then write, I don't know, there should be stuff. I'm probably running out of space here. To the left, to the left, followed by, I got into this last time. I don't know if I can or how I can embed like non-printable characters into this ASCII Z thing. So I'm actually going to not, and what I'm going to do is I'm just going to temporarily make 2 strings. And what will happen is I'm going to print this one, then I'm going to print a backspace character, or a carriage return character, and then I am going to print this string, and this string should show up on the left side of the same line, if everything is correct. So let's update our actual... Ooh, someone's calling. Oh, it is a person from work. Oh, shoot! Right, I am going over. Oh, no. Okay. Thanks for popping on and reminding me, Tom. On Thursdays, I have a thing. Oh, man, what a jerk I am. Thanks for reminding me. I'm literally going to run this, and then we will get out of here, because, yeah. They need me. They need me. It's very important. I am an important man. People like me and want to do things with me. Did I put a label on here? No, I did not. Let's call this here string, and I'm just having too much fun today. Okay. Here string and store a string pointer and load a the high byte of hello string and store a into string into string pointer. Good God, string pointer plus 1, and then call print string, and then in between the two of these load a literal 0D, which is the line or the carriage return, call print. Really, what the heck is the name of that? Puncture. There we go. Okay, and this should do what I say, and if it doesn't do what I just described, too bad, I have places to be. The tension. The tension. Okay. Well, let us resume this tomorrow. But we have made progress. I have borders. I really need to go. Thank you, everyone. Steve says you can do it. I can't do it, Steve. I can't. I gotta go. Okay. Bye.